All right, so now we're talking about factor by grouping. Now, this is a factoring technique I think is best explained through examples, but let me just talk about when you would want to use factor by grouping. So you've probably already learned different factoring techniques like AM method, maybe AC method, maybe difference of two squares that are used in different circumstances. Difference of two squares is used when you have two terms. Something like AM method is used to factor when you have three terms. GCF method can actually be used with any number of terms. Factor by grouping is something you're going to want to do when you have four terms in whatever thing you're trying to factor. Okay. Before going into this, I recommend you already know GCF method. That's something you need to know for this method, but the other stuff, not necessary. Okay, so let's just go through these steps of factor by grouping. How do I factor this into two smaller polynomials being multiplied together, right? Because that's what factoring is. It's basically you're reversing the steps of multiplication. So first thing is when you need to factor by grouping, you first check for a GCF, right? Right now there are no terms in common between any of these, so there is no GCF. Step two is you want to create smaller groups within this larger polynomial, and that's why it's called factor by grouping. You're going to kind of split this up into, okay, a 12x to the third plus 4x squared, and it's typically going to be your first two numbers and your second two set of numbers that'll be grouped together. We got a plus 3x plus 1 here. Now what you're going to want to do with each individual group is factor out a GCF, okay? And you're going to factor out a GCF in a specific way where you get the same term, and you'll see what that means in a minute. Okay, so for this first term, I'm going to factor out a GCF. It looks like 4x squared will be the term I'm factoring out. So here, 4x squared goes on the outside, and what's left on the inside should be 3x and plus 1. And here, it looks like the GCF is actually 1, so the inside is going to stay as is. Now, if you notice, these two components are the exact same thing. What that allows us to do is take that out of this whole term as though it were a common factor. So we take the 3x plus 1 out in front, and what's left on the inside? Well, 4x squared divided by 3x plus 1 should just be 4x squared. And what's 3x plus 1 divided by 3x plus 1? Well, that should just be 1. So we're left with a positive 1. And that's factor by grouping. All right? So this method for factoring should be pretty straightforward. It's also recognizing when you have to use it should be pretty easy because it's really the main factoring technique for when you have four individual terms. Okay, now let's look at some examples. All right, so in this first example, we have x to the third minus 5x squared plus 3x minus 15. I suggest you pause the video and try this out yourself. All right, so let's get into it. So first thing you want to do, check for a GCF in all terms, right? All right, so I don't see one here, so we can move on to step 2, which is creating our groups. So I think it can kind of easily be seen. Okay, you typically want to group your first two terms and your second two terms together, and then do the GCF with those. All right, so let's do GCF of x to the third minus 5x squared. If you have trouble with GCF method, I have a separate video for that. So the common term here would be an x squared. So I take out x squared up front, and what's left? X to the third divided by x squared leaves me with x. Negative 5x squared divided by x squared is just minus 5. Now let's look here. The common term here looks like a positive 3. So I take out a positive 3, and what's left on the inside? Well, positive 3 divided by x is just x. Or, sorry, 3x divided by positive 3 is just x. Negative 15 divided by positive 3 is minus 5. Now look, I got the same terms in here. That means I can factor it out as a common term. All right, so that's going to end up being, if I have x minus 5 on the outside, what's left on the inside should just be an x squared and a plus 3. All right, simple as that. All right, so this next term we have is 10x to the third minus 20x squared plus 6x minus 12. So let's go over steps for factor by grouping. First, look for a common term in everything. Look for a GCF, where in this case we actually do have one. It looks like 2 is something we can factor out. So 2 is going to remain on the outside, while this then becomes 5x to the third minus 10x squared plus 3x minus 6. All right, now what we're going to do is essentially we're going to ignore this 2 on the outside for now. It's going to be in our final answer, but in order to factor by grouping, we're only concerned with this, with these 4 terms in the middle, all right, or in the parentheses. So the next step would be to actually group the terms. And like normal, you're going to want to typically group the first 2 terms and the last 2 terms together. Okay, so we have a 5x to the third minus 10x squared and a 3x minus 6. So let's go on and do the GCF for each individual group. So this 2 remains on the outside. And now what is the GCF for 5x to the third minus 10x to the second? It looks like that's just going to be 5x to the second. And what's left on the inside? It should just be an x minus 2. And let's see, the GCF here looks like it's 3x minus 6. That should just be 3. 3 is our common term. So we take out a 3. And what's left on the inside? 3x divided by 3 is just x. Negative 6 divided by 3 is just negative 2. And we're left with these 2 terms being the exact same. Like I said before, it's what we want. Now we can take that out as a common term. So don't forget this 2 on the outside. And now we're going to have x minus 2 as our common outside term. And what's left on the inside should just then be in a 5x squared and a positive 3. Okay? And that would be our final answer for number 2. All right, now let's look at another example. All right, so let's look at this next one. So this next one looks a lot harder than our previous examples. Not only are the numbers a lot bigger, but we have more than one variable in our expression. Right? We actually have 4, not just an x, but we have an x, a y, a w, and a z. However, don't panic. The steps for factor by grouping are the exact same thing. Okay? So let me just show you by following step-by-step our procedure. What is step 1? It's to look for a common term in our entire expression. So our expression is 75x squared w minus 45x squared z minus 30 yw plus 18 yz. So what is the common term in all of them? It looks like all of these coefficient numbers up here are divisible by 3. So I should be able to factor out a 3 and get more manageable numbers. All right? So I'll put the 3 on the outside. And what I'm left on the inside, 75 divided by 3 is just 25. And then I still have the x squared w minus, what's 45 divided by 3? 15. X squared z. 30 divided by 3. I should just be left with a minus 10yw. And lastly, 18 divided by 3. That just leaves me with a positive 6yz. Okay, so that's step 1. Step 2, let's actually group our terms. So normally, we would take our first 2 terms and our second 2 terms. So let's do that. Let's do that now. The 3's on the outside, and I group a 25 x squared w along with a negative 15 x squared z. And that's going to be grouped with a negative 10 w. So I'm going to just write it like this, because I don't want to leave it without a sign there so you don't get confused by what's actually happening in terms of, because it's not multiplication that we're doing. And then I group that with the 6yz. Now I take out, GCF from each term. 3 remains on the outside. Now what's the GCF between 25x squared w and 15x squared z? That should just be, it looks like 5x squared. Okay, so I take out a 5x squared. What's left on the inside? Well, 25x squared w divided by 5x squared should just be 5w. And then 15x squared z divided by 5x squared should just be 3z. So minus 3z. And taking a common term out here, let's go for, it looks like within 10 and 6, I can actually either take out a positive 2 or a negative 2, or positive 2y or a negative 2y. Now here's the thing, I always want these terms to match. So if I took out a positive 2y, right, and I'm going to leave the sign there blank for a specific reason. So if I take out a 2y, what I get on the inside is a negative 5w plus 3z. Now here's the thing, these don't match up. I wouldn't be able to do GCF with them. But what if instead I take out a negative 2 instead of a positive 2? Then negative 10 divided by 2 would have been a positive 5, and a positive 6 divided by a negative 2 should have then been a negative 3. Okay, now we have these two matching. So let's do the final step for factor by grouping. This 3 still stays on the outside. We take out this common term of a 5w minus 3z. What do we have left is a 5x squared minus 2y. And that's pretty much it. So we'll just do one more example, and then hopefully you guys should be experts. All right, for this example, we're back down to a single variable. Now, the reason I want to do this particular example, you'll see in a minute, I want to highlight something we slightly touched on in the last example. So what does this expression say? 12x to the third minus 28x squared minus 24x plus 56. First step, we always want to factor out the common term if we see one. And it looks like here it will be 4, which I'm not doing that on purpose. I think example 2 was 2 and example 3 was 3. It's not on purpose. So factoring out a 4, we bring a 4 to the outside, and what's left on the inside should then be a 3x to the third minus 7x to the second minus 6x plus 4. And then plus, 14. Okay, so from here, we want to group our terms. Obviously, the thing we've been doing so far is grouping the first two and the second two. That typically is the way you want to do it. And then we want to take out a common term. So what's going to be our common term here? It's 3x to the third and 7x squared. It looks like the only thing we can take out is an x squared, right? So we have 4 and then x squared multiplied by 3, just 3x minus 7. Okay, now what do we take out of here? So this is something I kind of talked about. If you were to look at these and say, okay, looks like 2 goes into both of these, and you were to take out a 2, what you would be left with is negative 3x plus 7, which doesn't match up to this. Okay, and when they don't match up and you see the signs aren't exactly right, but the numbers are, then what you want to do is, instead of taking out a positive 2 like you were going to in this case, you would take out a negative 2, right? Just make whatever thing you were taking out negative, and then the sign should match up. So here, hit my camera, here we take out a negative 2, so this is going to be minus 2, and then negative 6 divided by 2 is positive 3x, right? And then we have a positive 14 divided by negative 2, we get a negative 7. The only thing left to do, factor out our common term, right? So 4 is left on the outside. 3x minus 7 is the thing they both have in common. What's left? X squared minus 2. Okay, just to briefly go over everything we just talked about. So for factor by grouping, it's really following a certain set of steps. Once you recognize, okay, I have 4 terms and I need to factor by grouping, right? That's the case that you're looking for to do this technique. Step 1, GCF on the whole thing. Take out any common terms. Step 2 would be group these terms into their own, like group the first 2 things together and group the second 2 things together. Then after that, within each group you made, do GCF on just that smaller group. And what you're going to want to try to do is get out the same term here. So that way you can GCF that, you can factor that out, and get just 2 binomials multiplied together. So hopefully that was made pretty simple. Hopefully you guys get it. If there are any questions, throw it down in the comments. But other than that, good luck.